The evidence mounts as to who is responsible for the blowout that caused the explosion that let loose the undersea oil gusher and sank the rig and killed 11 men. Evidence and the barest hint of progress in the BP Gulf oil disaster, all to report this hour. It's all coming up. But first, fish. Fish breathing, to be specific. It's biology 101, right? Human beings survive by breathing. So do other animals, including fish. We don't usually think of fish as breathing since they live in water, but they do. That's sort of what the whole gill thing is about. Like humans, fish need oxygen to survive. The gill system works by extracting dissolved oxygen that's in the water that they swim in. Because oxygen is vital to the very existence of fish, when fish find themselves in a low oxygen area, they tend to swim away from it. They try to get out of it. If an oxygen-deprived area of water is so big that they can't swim out of it, they die. Same goes for all the other parts of the marine food chain that depend on there being oxygen in the water in order to survive. Really, oxygen-deprived areas in the ocean have a name. They're called dead zones. There are a few hundred known dead zones across the world, one of them right off the coast of Oregon.
Oregon scientists this summer dropped a camera to the ocean floor and were sickened by what they saw. A deep, disturbing seascape. Everything from the largest crab to the smallest organism dead.
Not a single fish in this area. Lots of dead crabs littering the seafloor. Worms out laying on the bottom, obviously dead.
Dead everything, dead fish, dead crabs, dead worms. These dead zones, these areas of really low oxygen levels, can't support much life. Many dead zones are seasonal, or they appear on even longer cycles, every few years, changing shape, appearing and disappearing as pollution and freshwater seawater mixes ebb and flow. More than a decade ago, the New Orleans Times-Picayune newspaper won a Pulitzer Prize for their reporting on a huge dead zone that had started appearing every summer off the coast of Louisiana. It would cause fishermen in the area to have to go hundreds of miles offshore in order to find anything to fish, because all the fish in the dead zone were dead.
This summer, it covered more than 7,700 square miles of the Gulf, about the size of New Jersey. Shrimp, fish, clams, and crabs flee it. The people who fish here call it the dead zone because nothing survives 10 feet below the surface.
I'd put my line down. It's just dead. Nothing's happening.
Nothing survives 10 feet below the surface because there isn't enough oxygen down there. That huge dead zone in the Gulf of Mexico is believed to be caused by pollution, by fertilizer runoff from the Mississippi River. There were fears that if there weren't curbs on that kind of pollution, that particular Gulf of Mexico dead zone might become permanent. But if you think pollution has made that part of the world very fragile already, you ain't seen nothing yet. Over the weekend, a team of scientists on a research vessel called the Pelican discovered a, quote, shocking amount of oil floating underwater. Massive plumes of what they think are oil and chemical dispersants that are, in at least one plume's case, 10 miles long, 3 miles wide, and 300 feet thick. Officials are still trying to determine the exact consistency of the underwater oil plumes. How much oil is there mixed with water? What else might be in those plumes? But scientists on board the Pelican say they are already measuring 30% lower oxygen levels in the areas surrounding these plumes. The New York Times, reporting on these findings, explains, quote, while the oxygen depletion so far is not enough to kill off sea life, the possibility looms that oxygen levels could fall so low as to create large dead zones, especially at the sea floor. That's the big worry, says the head of the National Institute for Undersea Science and Technology, which sponsored the Pelican's research mission. Before BP can even begin to wrap their heads around the potential decades-long ecological disaster they may have wrought in the Gulf, they have to come to terms with the fact that they are still wreaking it. They still have to plug the well that is still gushing. That effort continues today as BP has managed to send down a mile-long tube that they stuck into the oil stream. They say that tube is now siphoning off about 20% of the oil that is coming out of the broken riser pipe. They also have plans to fill up the gushing broken riser pipe with drilling mud or possibly debris like rubber tires, what everybody's been calling the junk shot. In the meantime, BP just started drilling a second relief well near the site of the disaster, but it will be months before those relief wells could be operational. All of this in an effort to stop the actual leak. And even when that happy day comes, we will still be facing the question of what to do with the oil that's already floating out there, floating around somewhere. Possibly, we now realize, suspended underwater. How, in the name of thousands of square miles of potentially dead marine life, do you possibly clean that up? Joining us now by Skype is science journalist Mark Schroep. He was on board the Pelican research vessel for 8 days on behalf of Nature magazine. He just got back to land yesterday. Mr. Schroep, thanks very much for joining us tonight. I appreciate your time.
Hi there. Good to be here.
So first of all, I know you were out in the Gulf with these scientists for days, observing this, the oil that's out there. Set the scene for us a little bit. Is it clear when you're there that you are amidst the oil, or is it all under the surface?
No, it's clear, but it varies. Early on, the seas were a lot calmer, so there was more oil bunched together. By the time I got there, the seas were a little larger, so things are broken up. But you definitely come through, depending on where you are, through different bands of oil, and you can see large brown bands off and on. More so, especially because of the way the winds were working. I believe it was to the west side of the accident site, and you smell a lot more there as well.
So the smells that you're out there among, does it smell like a gas station? Does it smell like a refinery? What does it smell like?
It smells like oil more than gas, so it smells more like adding oil to the engine. But it's pretty pervasive in places.
How did the scientists that you were with discover what they're describing as these underwater plumes? What sort of scientific techniques are they using to be able to find these things? They are, after all, not visible to the naked eye from the surface.
Well, they were using a number of different techniques, but the one that became key for looking at that plume was something called a CTD rosette. It's a group of water sample bottles and different pieces of measuring equipment that are all added to the same frame, and that frame is dropped down all the way to the seafloor and then pulled back up, and it sends readings up through the cable in real time while that's happening, so they can see what's going on.
And when you're on board the Pelican, when they're doing these tests, when they're getting these readings, when they're using that type of equipment, is it clear to the scientists right away the sort of thing that they're dealing with? Were they able to describe on board, on ship, what they thought they had discovered, or is it the sort of thing that takes after-the-fact analysis on land?
Well, they were certainly able to speculate, but there's a lot that they don't know. In fact, you could almost say there's little that they can say about the plume until they run samples this week to figure it out. But there was certainly enough information so that they could speculate and try and come up with ideas that would explain what they were seeing.
I understand that NOAA, the National Oceanic and Atmospheric Administration, which is in part funding these scientists, NOAA is warning that they can't verify that anything that's being found underwater in terms of stuff being suspended in the water column, they can't verify that these are plumes of oil or oil mixed with dispersants. As a journalist, what's your dispersants? Excuse me. As a journalist, what's your understanding of what happens next in terms of verifying what's out there? What do they do next with the data that they have collected?
Well, there's a group, the people that were out actually are not geochemists, so they were collecting samples for a lot of different colleagues that were interested in looking at things. But they have a woman named Samantha Joy that they work with that will receive, I believe, most of the water samples, and she'll do a number of analyses. I don't know, I think there was some talk of possibly sending portions of those samples to different labs with other agencies or something along those lines, but I don't really know the details of that. But there will be a lot of analysis, I would assume, fairly quickly this week.
Science journalist Mark Schroep, who was on board the Pelican research vessel until yesterday, joined us tonight via Skype. Mark, thanks very much for your time. I appreciate it.
No problem.